Hello, friends. Welcome to Containers from the Couch. I am today's host. My name is Ray Kruger. I'm a principal container specialist with AWS. I'm joined here today by my good friend Cy Venom and our partners from SpectroCloud. Today, we're going to talk about managing clusters. We're going to talk about managing clusters of clusters. We're going to talk about some virtual clusters. We're going to talk about the word cluster a lot. But first, before we dive into all of that, we'll do a quick round of intros. Cy, why don't you say hello?
Hey Ray, excited to be a co-host for you today with our friends from SpectroCloud. I think what the team over at SpectroCloud is doing is honestly innovative. It's different, and today, hopefully by the end of the episode, from the demos we see, from talking through some of the solutions here, you at home will also see why what they're doing with managing Kubernetes clusters at scale is different. It's unique, and I think can offer a lot of value to our customers that may have a lot of operational overhead today with managing Kubernetes. So excited to be here, excited to see the solution. Let me pass the mic here over to Justin.
Hey, Cy, thank you so much for having us. Really excited to be on the show. My name is Justin Barksdale. I'm a principal architect here at SpectroCloud and looking forward to showing you how we are enabling Kubernetes management to be easier, faster, and more reliable. Alex?
Thanks. Ray, Cy, pleasure to be on the show. Thanks for having us. I'm Alex Sharoma. I'm a senior solutions architect here at SpectroCloud, and I'm responsible for the technical relationship between SpectroCloud and AWS.
Great. So in the world of managing Kubernetes clusters, right, there's a lot of open source tooling that's out there. We see customers frequently, bringing a lot of this tooling together to manage their clusters, either from the state of just being able to create one to managing estates of clusters, and then trying to figure out where that dial should be on things like multi-tenancy. Should we have more clusters or should we have more tenants? Blast radius and all those sorts of things. So I'd love to hear where SpectroCloud kind of comes in versus the DIY open source approach of kind of building out some of this tooling.
Yeah, absolutely. I think what you said, there's a lot of DIY that's out there, which ends up creating a lot of complexity for a lot of our customers, and having to piece those things together can be a challenge for a lot of people. And so what we're doing is trying to simplify that entire process and deliver clusters, Kubernetes clusters to our customers through any location at scale.
Great.
And I would just add, Ray, certainly DIY approach is something that a lot of people have done. There's been tooling that's enabled it to be a bit better. Things like Cluster API have come on board to help manage infrastructure and building Kubernetes clusters. And that's really an area we kind of tackled very early on, adopting what Cluster API is doing, extending it a bit in terms of the concepts to be more than just infrastructure, because, Kubernetes is not necessarily the end result. We need to make sure we're providing something that our customers are going to be able to deploy something for their customers, like applications, and that's really at the end of the day what we're trying to provide as a platform to deploy those faster.
So I like the notion of grounding this in something that our viewers are probably already familiar with. So you mentioned Cappy, Cluster API, which is very, very popular way of working with Kubernetes, deploying, distributing Kubernetes, but you seem to hint that it was really just focused on like the infrastructure aspect. So we're saying that the solution SpectroCloud offers, I think Pallet specifically, does it go beyond what Cappy offers, and how so?
Yeah, so the solution is called Pallet, and it extends the concepts of Cluster API, which is really about self-reconciliation, healing, to the layers beyond just the sort of 4 infrastructure layers that we're all probably familiar with: the operating system, the Kubernetes distribution version, the CNI and CSI. So taking the steps to provide configuration management, prevent configuration drift in those additional areas. And we do that through an agent that we have that provides the similar type functionality what Cluster API is doing, but at a more broad level.
Great. So we've set a little bit of context here. I think maybe we want to going to dive a little deeper into what cluster API sort of is and isn't. Alex, you want to get us rolling on that?
Yeah, absolutely. I mean, cluster APIs, is Justin mentioned, is the foundational framework for what SpectroCloud Pallet is built upon, and ultimately we integrate uniquely with and extend. But we actually talked to a lot of our customers who aren't super familiar with cluster API, so I wanted to level set and make sure everybody's aware of what ultimately it is. So cluster API is a Kubernetes subproject within the CNCF SIG, with the goal of bringing Kubernetes style APIs and the declarative approach we talked about to the cluster lifecycle management, which is, that includes the creation, upgrade, and destruction of those clusters. And it's designed to work across a variety of environments, and provide a reusable set of components and stuff like that. So as you can see here, there are a number of different ways to bootstrap a Kubernetes cluster today. Sure, everyone on this call is familiar with cloud-specific tools like EKSCTL, the Kubernetes providers like KubeADM, and even infrastructure as code solutions like Terraform, right? And all these are great tools in their respective use cases. However, cluster API attempts to standardize that process by extending similar principles of Kubernetes, namely the declarative APIs and the operator pattern. And that brings automation inside of Kubernetes. And so operators extend the idea of that control loop to continuously monitor the current state of the cluster and reconcile it with that desired state. It creates custom resources for the Kubernetes API objects that they then watch and reconcile via those controllers.
So Alex, this is great, and I think a good recap for folks watching for how Cappy works. But Justin hinted that we go beyond that. So curious to see where and how do we take Cappy even further?
So what we do is extend that up the stack, right? We utilize a cluster profile, which then manages, right, the different layers above the infrastructure layers that we mentioned as far as what Cappy provides. So
we create. I'm sorry, Alex. Just to summarize for a second, we create similar custom resources that have a declarative nature of what the desired state of the cluster is beyond just what Cappy understands, and then we have operators and agents that in the cluster that understand how to deploy those, whether that is a Helm chart or a manifest, or as Alex alluded to, something we call packs, which is basically an extension of either of those. Our agents understand how to apply those to clusters in various ways and make sure that they're continuously reconciled for your desired state to be met.
So that sort of gets you from the next step, right? Like we use Cappy, we use Cluster API to create clusters, but then there's usually a bunch of stuff we want to install kind of after the fact, and you all cover that with packs, it sounds like.
Correct.
Got it. I know we have. I think you had one or two more things here you wanted to hit, Alex, before we jump into the demo time that everybody knows and loves here.
Yeah, absolutely. I think kind of the big thing here is that Cappy is declarative management, right? And if you think of it in the way you manage Kubernetes constructs, everything is through a declarative approach. So why wouldn't the life cycle of that infrastructure be defined and managed in the same way? And it's simple to read, it's intuitive, describes what the desired state should be, not how it should be. And it's very useful regardless of where you're going to deploy it. It just works over and over again. And ultimately, this is a presentation from Andrew Clay Schaefer. It's a great quote here, I think. A good job configuring servers this year, or good job configuring Kubernetes this year. said no CEO ever, right? There's so much more, as we'll get into, beyond the infrastructure layers that are make management and operationalizing Kubernetes a challenge at scale.
It really is a thankless job, because when everything is working perfectly, then, oh, great, you're doing your job. But the second that anything breaks down, it's all your fault, actually, as a Kubernetes operator. So this is, I think, my number one thing that I like to hit on as advocating for some of these solutions is, how do we make the operators' lives easier? Because believe me, it's not easy, and no CEO is thanking them for operating their servers well.
Absolutely.
I mean, it should be, but probably not.
So Justin, you want to dive into the demo?
Yeah. So so I'm gonna just kind of jump into our platform. This is Pallet. I have created what we call a project, and a project is just sort of a boundary for this particular environment. And inside that project, I've created a cluster profile. Now, as we talked about a moment ago, a cluster profile is sort of the declarative state of what a cluster should be beyond just the Kubernetes components. In this particular environment, I've created a pretty basic cluster profile and a couple of different versions of it. So I've got a cluster profile here that is running Kubernetes EKS 129. We're installing a CNI, CSI, Nginx, OPA. You could, add in manifest for OPA to provide different policies that you may want, and then just like some basic application, WordPress and Hipster. And likewise, I have a similar version that I've deployed already, which is version 128. Really, the only difference between these is the version themselves and the version of Kubernetes. And while we talk about the profile and these layers in this concept, really it gets down to who's the person building this. And we want the person building it who's most likely not the person consuming it. It's most likely not a developer who's responsible for building these profiles. So we give that Kubernetes operator the ability and flexibility to tweak the knobs they need to. And so you can see they have really complete control over what that pack might be within the profile. And then they can save this so that it can be consumed upstream. Now, we have a very robust Terraform provider. Everything that we can do in the UI is also available via the API. We're an API first platform. And so when I look at this, I can turn around and say, let's build some number of Kubernetes clusters. And I've defined those clusters within my some Terraform code. Now it's Terraform behind the scenes. We've kind of what we call simplified it, making it look more YAML, because we found that a lot of customers may not understand Terraform. So it's a bit easier to read in this context. But as you can see, I've got a number of files that basically just define what a cluster should be. So what's the name, any tags I want to provide, what's the cloud account. So in Amazon, I may have different projects for different teams, different cloud accounts for different billing units. And so I can define all of that within my code, along with my profiles and maybe any other additional configurations, like, do I want to put it in this particular VPC with these subnets? Is it public? Is it private? What's the node group size? And all these things. And then additionally, I can configure things like backup policies, and we can create a backup policy that backs up to S3 as an example to integrate a little bit further there. I've already defined and built all of these, so I'm not going to go through, but the thing to point out is, we've basically said the version of EKS here is 1.28. And the version of our monitoring is 1.0. So looking at this particular cluster, I've called it prod 02 in US East.
And Justin, those are specifically the versions of the packs themselves that you're deploying?
That's correct.
Oh, cool.
Well,
so the packs themselves are all version managed as well.
Yes, this is the version of the profile, but the packs are also versioned behind the scenes. So if you go back to our slide here, you'll see my profile version is 1.28, but like my Kubernetes pack version also happens to be 1.28, just happens to coincide. But for example, Nginx is 1.1 or 1.10. So it doesn't necessarily mean that the packs are the same version, but it means this profile that was built, which contains all those packs, this is the version that we want to deploy.
So just not had a question about the YAML that you were showing there. That was not a Kubernetes resource, and I know that because it doesn't look like a CRD. So this is YAML, but it's something that's being read by Pallet, not Kubernetes, right? There's no operator in Kubernetes that's reading through this config.
Yeah, I mean, hidden behind the scenes, this is a module that we wrote for our provider, again, to simplify for our customers. At the end of the day, you could consume the provider just like you would any other Terraform code. But what we found with many customers is, especially at kind of scale, it's difficult for them to understand Terraform. And this is easier and more readable and more repeatable for them. So rather than show the complexity of how Terraform can be, especially when you have all these different configurations, cloud configurations, backup, node pools, and these various things, we took a module and wrote it for our provider that makes it look more readable and as YAML.
Gotcha. The reason I bring this up, I recently read a really interesting blog from Figma on how they migrated to Kubernetes in less than 12 months. And one of their key takeaways was keep raw Kubernetes YAML from users. They had built something very similar to this, which basically wraps the different things that their end users within the company might do with Kubernetes, like deploying an ingress or a service or a load balancer or any of the things that you showed, like Carpenter, and they created kind of almost natural language around it. Not fully, but they kept the raw YAML away from their end users. And I love that you're showing essentially that here is look at all of the layers of the stack you can build with just a few pieces of config. You let the ops team figure out how this stuff works behind the scenes. I think this aligns really nicely with the huge, platform engineering motion that we're seeing lately with Canoe, Backstage, and all of these other tools. I think it aligns really nicely with these platform engineering initiatives.
Yeah, exactly. And the goal is, as you kind of hit, when you look at, something like, well, not necessarily just Kubernetes, but let's take a look for 1 second back at a different profile that I also created, which is around monitoring. And I just kind of wanted to show, if you look at monitoring, and this is Prometheus and Grafana, again, very common tool set. But if you look at what is in this and what you would have to configure if you're the operator in terms of, I'm going to go do the Helm chart, there's something like 3,000 lines of code here. And, to know which knob to tweak and things like that is not necessarily a very good use of their time because they're just trying to consume it. So as a platform administrator or as a subject matter expert in monitoring, you can build this for them. And all they really need to do is just reference, okay, we need to use monitoring pack or monitoring profile version 1.0. And behind the scenes, they don't need to know that, this is all the stuff that's going on because the subject matter expert has already defined that. So it's really kind of just trying to simplify and get to market a platform that a developer can consume in a much easier and quicker manner.
What's the significance of the order of the order of that stack? Is it the order in which things get deployed to the cluster? Is there significance there?
Yeah. So by default, we have order priority, install priority. The default is that everything is the same unless you change it. And so with the exception of the base 4 layers, which go in order, operating system, of course, first, Kubernetes, then CNI, and then CSI. But those all go in that order. There's really no way to change that. But then beyond that, it's kind of up to you. So for example, if I said I want Nginx to be installed before anything else because it needs to provide, an ingress before something else, I maybe make the install order something like 0, or we can do negative numbers, which would in turn just make it install before everything else, but after the infrastructure. Likewise, if I said, I need Hipster to be the absolute last thing that's installed, I could say, the install order is 10. And now it automatically will be the last thing that's installed. If you don't set an order, it's sort of in parallel. We just do the deployment. So you could end up having some race conditions if there was dependencies beforehand. It lets you kind of map those dependencies as needed.
That's really cool. I like the visualization there.
Yeah, the meta point that I was going to make there is one of the things that I talk with customers a lot about, especially like platform teams, platform engineering teams, is this product concept, right? You're building a product, right? It may not be facing your external customers, but it's facing your internal customers, right? And so being able to kind of take this concept all the way down to the specific, like the pack becomes a product, right? And how do we upgrade the components that go into that and that go into the clusters above it? So
yeah, exactly. And we see a lot of customers build in their pipeline. They'll say components of their product or their application that they're building and customizing become a pack and a pack version. And so when they release a new version of their particular component, that then creates a new pack that also creates a new profile snapshot so that they can have it all bundled and released as a product if that's how they choose to desire. Other customers also, pick and choose. Oh, I only want this version to be upgraded of this component, not the whole thing. So it is entirely up to how the customer wants to consume it, but giving them the flexibility is really something that we strive for.
great. Yeah, I think Sai and I have gotten very excited about the pack concept here, and we should probably move forward.
So just as a note, I mean, then we can eventually just say, okay, let's upgrade a Kubernetes cluster. It's as simple as, making a change in a line of code and committing this change. I won't go through that process, but because it does take some time, because it is upgrading Kubernetes, but we've defined a pack or a profile with all of the best practices that we see there, and a user can just consume it. But now that we've sort of built some clusters and we have some number of them here.
Justin, I just want to point, you showed something really cool there, which is upgrading clusters by just flipping one number here. And that's not going to just upgrade the cluster itself, but all of the resources that may or may not need to be changed, like the CSI drivers, CNI drivers, everything else.
Correct.
Is this doing this in place, or are you doing some like magic behind the scenes, like blue-green type stuff?
We're doing, so it's rolling. I mean, we do it in place, but Cappy handles so again, this is built on Cluster API, depending upon the environment, but as an example, EKS, it's a scale up. So a new node is deployed with the new version. Well, the control plane's upgraded. Behind the scenes, you don't see that. Then the new node is deployed with the new version. When it's healthy, the workloads are drained off of another node and then sort of roll it so it goes through it automatically. And we don't really do any magic. We just leverage the power of what is already built within.
This is, by the way, how most.
Yeah, go ahead.
No, that is how most customers upgrade Kubernetes today. They're not doing blue-green unless they have a really good reason to do blue-green. So in place is the right approach, just updating the components that need to be upgraded. Such a big pain point for our customers.
Upgrades are consistently in Kubernetes land, wherever you are, one of the hardest things to kind of deal with. And what I really like about the pack concept is the reason that upgrades get stalled out is because, sure, it's the Kubernetes version, but I have all this other stuff installed that I need to test against that Kubernetes version, right? And there's different ways to organize those things when we talk about GitOps and such. So having this stack concept where you can say, look, we've already tested it, we're moving it forward through our environments as one kind of holistic upgrade is pretty powerful. And so take that home, people. Upgrade your clusters.
Yes.
Yeah,
and go ahead. Sorry.
Beyond that, right, is the intelligence between the layers and of the packs, right? So if there's a compliance issue between one version of a pack and another piece of the software stack, we won't let you perform that upgrade. And we can actually restrict your clusters. Restrict you from deploying that or any dependencies required for it.
Yeah,
have to go to Ticker up there, upgrade them.
Right. Exactly. And I think to Alex's point, just one more kind of focus on profiles for a second. We can do things like when we create a new profile or a new pack and we publish it, you can put constraints around it. So I'm going to go very, very quickly here and create a new profile. We'll call it Carpenter, as we've been working on a Carpenter add-on to be integrated with our environment. It's a type of add-on. And this can all, again, be done via Terraform or done via API, but just kind of showing you the simplicity here. I'll add a new pack, and the pack that we have is called Carpenter. So But one of the things we've added in here is constraints. It says, hey, you can only deploy this on EKS, because remember, we're building profiles that could potentially be deployed on any cluster type, on premises, edge. We have quite a bit of edge customers that are leveraging Amazon as well, and they want to have a common stack. But we want to make sure that they're not deploying components on edge that won't work on edge. So, we can put constraints within the pack. We can put dependencies that require specific versions of Kubernetes to be enabled. And I can very simply say, all right, let me select Carpenter. Again, the subject matter expert can change whatever they need to change that within here, and then create it and publish it. And now for a user, they could say, oh, I need to install Carpenter with my Amazon environment, and we would install Carpenter, and we can behind the scenes make some configuration changes that are required, such as adding IAM accounts and roles and whatnot to support that. So I think the power of a pack is really built in the fact that you can provide constraints. It is an extension of what you might do with Helm, but it provides more value in terms of being able to add that metadata that puts constraints that need to be applied.
For folks watching at home, if you're wondering what platform engineering is, that's what platform engineering is. It's the ability for some SME, the operator within a company, to say, look, I know that Carpenter is something that's going to help everyone out, and I know how to configure Carpenter. Let me just save a template, which I know works for these types of clusters, 1.29 with Nginx, controller, blah, blah, blah. I know that this Carpenter configuration works. You save it, and now anyone else in the company that wants to use that pack can just click a button, add it on. I think that's platform engineering at its best. And not everyone needs to know how that Carpenter stuff works underneath the covers. By the way, I saw when you exposed some of those YAML in the Carpenter pack that there's an actual Helm chart in there that's being configured as part of the pack. Amazing. Mm-hmm. It's the best practices for how to install. Totally customizable, but not everyone needs to know how it's done.
Yeah,
exactly. So now that we have some clusters deployed, I've got a number of them. I'll focus on sort of we've deployed it in 2 different regions. Same profile, but 2 different regions. And so the kind of next step is, how do I help my developers maybe consume these a bit faster? And so we have a concept called cluster groups, where we can create a cluster group, and within a cluster group, I could say, let's call it cluster group 02. And then I can pick which clusters I want to be a part of it. So maybe I want US East 2 prod and EU 3 prod to be part of it. I have these selected. You can see, I've got plenty of memory and CPU, whatever. But the next thing is, okay, do you want to allow oversubscription? Do you want to allow your consumers to be able to maybe oversubscribe the applications, or in this case, virtual clusters? What type of ingress or endpoint do you want to have? We're going to select a load balancer, as Amazon provides this for us. And then, from a virtual cluster, which behind the scenes is ultimately what we're doing, from a virtual cluster configuration, you can set this up how you want. Do you want to enable some of the underlying resources like storage and whatnot to be exposed to this? A lot of different configuration elements. Again, platform engineers can set this all up, basically create. If they wanted to attach an actual one of our profiles to it, they could, to present to a developer and say, okay, here's your group of clusters, go deploy whatever it is that you want. And you can break it, you can test with it, make changes, because at the end of the day, what's being provisioned is an actual V cluster. So when they look at it and you look at what that cluster might look like, here is the inside of that's been deployed on top of EKS. That just happens to be V cluster, and as a developer, I could break this and it wouldn't impact anybody else. We can respin it back up very quickly, providing a lot more flexibility for them to be able to test and break things.
So are you running
summarize what I think I heard? Cluster groups are collections of virtual clusters?
Other way around, cluster groups are collections of physical clusters that you then would use to deploy virtual clusters on top of.
So your cluster group, was that 1 or 2 EKS clusters? And then how many virtual?
Yep. So this one here is 2 EKS clusters. And then I've deployed 2 virtual clusters to it. So I've said, hey, deploy 2 virtual clusters.
And it'll handle it already kind of, round robin, deployed one on each. And you can
Yep.
deploy more virtual clusters on that infrastructure as well,
Yep.
right?
So I can either through this mode, which is kind of the platform engineering mode, I can say, let's create another virtual cluster, add new, what do we want to call it, or what group do we want to put it on? Let's put it on the new group we just deployed. We'll give it a name. We'll call it virtual cluster 3. We can, set our quotas or whatever we want to put in terms of memory and CPU. Again, the oversubscription rules are there. So if we try and assign too much, we won't be able to. But I'll select it, any add-on profiles. Remember, these are profiles that we've created within the platform. So, I need to have, I wouldn't install Carpenter, it wouldn't work, but I need to have monitoring, or I want to make sure I want to test Nginx, or whatever it is I'm trying to test can be a profile. And then I can attach it to my virtual cluster just like it was any other cluster. So my view is I'm testing something that I want to, not necessarily performance testing, maybe it's integration testing. And I want to make sure all the components that we'd have are part of that. I'll just click next, and in a few minutes, it takes a few minutes for the first one to spin up because we have to download some pods and things like that. But once the pods are local, it will be, it's within 30 to 60 seconds, a new cluster can be spun down, whatever.
This is really cool. I think it changes the way that developers are able to spin up test environments, not just developers, but automation frameworks, getting GitOps working really nicely. I can see it's already kicking off that provision. So quick question, I have to ask this. So the ClickOps experience, beautiful, works, very nice. What about for developers that want to automate some of these things, right? Like they want to virtual cluster spun up in response to a PR on their Git repo, run some tests, and then spin back down.
Yeah, so we provide, I'm just going to walk through this one more time. We provide the ability for you to see the API call that we're making at any point. So you could take this, roll it into your pipeline, make your variables that you want. And, if you're choosing API, again, we have a Terraform provider too, if that's your poison. We've also recently released a crossplane provider for those that love crossplane. I love crossplane. I think that it's very complementary to what we do, but we have a provider for Pallet as well. So all of these things can be done. There's an SDK. I mean, there's a lot of different ways to do this, but we provide, again, we're API first. So anything that you can do in the UI can be done via an API. And we, try to provide you some simplicity. And here's the payload that we do if you were going to make this, create this, take this and variabilize it and roll it into your pipeline as you need to.
Super cool.
Yeah, that's very cool. So you could have a whole pipeline that uses the virtual clusters to do integration testing, as you mentioned, basically deploy everything and then wipe it clean while leveraging, the exact same underlying EKS, cluster resources. Yeah.
And the user doesn't know that, right? They don't know what is underlying. They just know that they're getting a Kubernetes cluster. And so we've kind of been focused very much right now on that view that we just saw was, I would say, like more platform administration, but what about the developer? And we're developing and iterating over this, but sort of a development view where I don't necessarily, again, care about the infrastructure. I just want to spin up an application. So I can publish apps as a developer. I can then test them by just saying, okay, let's add a new app. We have a couple of apps that are published as examples. But so I'll select a profile that's there. We'll pick Marvel as an example. Do I want to create a new virtual cluster? Do I want or deploy it on an existing? I could select either of these. I'll say create new. And which cluster group do I want to use? So let's say cluster group 2. It's really that simple. Okay, how big do you want it to be? Again, the API is available, so I can make this exact same API call and do this over and over. Create the app, and this will spin up a virtual cluster while also creating whatever the application was that I've published. And if I'm a developer, it could be some version of that application. It really gives you an ability to have some element that is independent of having to worry about what's in the platform.
Justin, while I go through this, I'm trying to think how customers will get most value out of this type of framework. And I really, I don't think it's going to be customers that have like production versions of their apps in here, but I'm instead foreseeing that, like an internal CIO team or internal tech group that vends clusters for other teams within their company, they're the ones that are probably going to create, like, here's a base Node.js app, here's a base, Rust app, whatever it might be. And then the teams that need a Kubernetes cluster to develop some microservice, some requirement for their solution, goes in here and says, just give me this app profile on a cluster and I'll run with it, right? It's giving that all of that plumbing for the end user, the team that needs to develop some service. It says, okay, give me something I can mess with, and then they can focus on the code itself, the application itself. I think there's a lot of value from that platform engineering perspective to use something like this.
Exactly. And one of the areas that I think development struggles with Kubernetes is that if you give a cluster to a developer group and you say, oh, you guys can just use this as a group to develop, when they're developing things like CRDs, those are cluster wide, and it's very difficult. You can have overlap, you can have conflict, and so being able to spin up a virtual cluster in a very quick manner, have someone test their CRDs that they're doing, and then eventually promote that to, say, the next stage of their development pipeline, which might be integration testing, or it might be on their larger, actual Kubernetes cluster. It really gives an advantage, I think, in terms of being able to iterate and then not step on each other, which is something that we've seen a lot in different customers.
Yeah, definitely compelling use case for sure.
So the last thing I'll just kind of go back and show is, we do have, as I switched earlier, you probably saw from app mode or cluster mode to app mode. I'm going to switch back to cluster mode just to kind of show you. And this is just a visualization. So really, when you're thinking about, platform teams or which team is roles or responsibilities, sort of the last kind of thing is workspaces. It's this idea that, again, cross cluster, I want to be able to create a workspace that maybe is a namespace for, team A. And as part of this, I can select my clusters that I want to be a part of it. And when I do this and say, let's make this one, and this one part of it, I can, again, see what resources are there, but then I can start adding things like, okay, let's create a role binding, or let's add a role binding to this particular namespace. I won't configure all of this, but let's say the namespace is called Team A, and let's put some quotas around it. Like, let's let them have, 8 CPUs and 24 gigs of memory or something like that. And so once I do this, I can't do that because it exceeds. Okay, I gotcha. Anyways, once I do this, it's not, okay. Once I do this, then I have a namespace that has some quotas around it, and the cluster itself can then, the clusters, all of them will have this same policy. And likewise, I can configure backups, again, pointing this to an S3 target in Amazon. So my backups are always there. And this is namespace specific. So as a platform administrator, I may then hand this namespace and the kube config that's attached to this namespace user to a development team. And now I don't have to worry about them, again, trampling on others.
So
which becomes a powerful feature.
Being able to create these like multiple roles, multiple role bindings, quotas, the namespaces, it sounds like, that are applied across multiple clusters. That's huge and very important. And I'm now, again, really curious about the not ClickOps approach here. So I'm assuming that API link up there in the corner is still documenting for us. So this is really cool. So now I can have, like, my permissions and policies as code up in a GitOps repo that's actually managing it across an entire collection of clusters, if I'm hearing that right.
That's correct.
That's awesome.
Behind the scenes, we deploy Kyverno. So on the clusters, Kyverno's there, and then the policies that are relegated for that are part of that as well.
Awesome.
But just ultimately, that's how it happens. That's how it happens. So, yeah, I mean, so I think in a nutshell, the focus is really how do we make operations of Kubernetes clusters easier? I think if we look at, upgrades, as we talked about, are a really big challenge, and being able, from a platform administration team, to build something that you can just be consumed by the end users, then I don't have to worry about, is it going to conflict? Is it going to cause a problem? And then simple as changing a line of code. I'll give you one sort of anecdote. We had a customer that had a security vulnerability in a couple of hundred clusters. And before us, they had it would take them probably 2 or so months to patch all of those. When they deployed, they had Pallet in place, and they had these clusters under management. They were able to patch those 200 clusters in about 4 hours. So it saved them a significant amount of time. And the fact that they were able to declaratively identify what that profile should look like based on the new version of this application that had the vulnerability, and then roll it out in such a quick manner, was something that we were really, really proud of. And I think that will help a lot of customers.
Yeah, I think that's really what we love to see here is when some of the partners that we work with, like SpectroCloud, like when you create solutions that are enabling customers to better implement best practices, it's a great thing to see. And we know that our customers do struggle sometimes at scale when it comes to things like managing all of these open source components, managing the life cycle of them, upgrades, that kind of thing. And to see that there's partner available solution here, it's pretty neat. I know SpectroCloud does a lot with open source and cloud native computing foundation and that kind of thing as well. Would love to hear a little bit about some of those projects that you're working on.
Yeah, absolutely. So one of the first open source projects that we're the main contributor on is Kairos. It's an immutable operating system for Kubernetes. Just recently graduated to the CNCF sandbox stage, and we're really excited about the capabilities it provides us for secure edge architecture. The other project we are sponsoring is the local AI project, which is a self-hosted open API drop-in replacement for that runs on Kubernetes, works on CPUs, which is awesome. It's got a great reception from the community. I think there's over 23,000 stars on GitHub today. Obviously, cluster APIs we've talked about extensively during this project. We've contributed quite a bit back into the project, bug fixes, as well as we wrote the canonical mask provider for cluster API. And then Validator is a new project we spun up recently. I'm on the wrong side, sorry. Which is a pre-flight validation framework. So, every environment you go into is unique and different. And, there's always best practices and requirements around security and accounts and networking. So the pre-flight validator will actually go in and check that those regions, those IAM permissions, the quotas available for a particular service, et cetera, so that we can go and deploy.
And I think just to kind of elaborate for a second on Validator, we've deployed Cluster API across many different environments and many EKS environments. And one of the most common thing we see is the permissions aren't correct. And that's, really, it's one of those things that's a lot of different configurations that need to be set, and they need to be applied in the right place. And so Validator is really a tool to help customers adopt Cluster API quicker. It's also a tool that we use for our pre-flight checks for our customers. So we're able to go in and say, run Validator. It will provide us a report back, and for the customer, they can see, oh yeah, I don't have this permission, or you know what, I don't have the right resource quota for a specific cloud region. I need to increase my my requirements. So it's very, I think, an underrated tool, but it's very powerful.
Yeah, and some of the cluster API use cases. So for me personally, I work a lot with our hybrid and edge customers around things like EKS Anywhere, which is all built on cluster API as well. And that's one of the things I really love about the logo is that it is literally just turtles all the way down when it comes to clusters, creating clusters, and it kind of blows people's minds. So where did SpectroCloud kind of decide to get involved with cluster API versus kind of any other direction?
So it was very early. I mean, it was one of the first things. I mean, it was sort of a founding principle when SpectroCloud was founded. It was based solely on, hey, cluster API is the way to go. One of the biggest reasons was it being a SIG project. It has a lot of community support. And I think the really biggest challenge that we saw was when you're trying, when we're trying to deploy Kubernetes to different infrastructure types, that abstraction of the infrastructure complexity is something that's really important to make it consistent. And early on, one of the things that we saw as a gap was like MAS, as Alex talked about. MAS is Metal as a Service from Canonical. We wrote the provider for that, and it's one of the ways that we got in really big partnership with Canonical was because we were able to show them this. They saw it. Actually, we ended up doing a couple webinars with them, and ultimately we are the maintainers of that project. But it was really, I think, Cluster API is a founding principle of the organization.
Great. And one of the checking the clock. One of the other things we did, we talked a lot about SpectroCloud and AWS. And of course, SpectroCloud supports other clouds, which we're not going to talk about. But I do know you guys also support edge use cases as well as a pretty big part of this as well.
Yeah.
We didn't really even talk about.
Yeah, I mean, it's a pretty big market for us. The edge in Kubernetes has grown up in the last couple of years, and I think it introduces a whole realm of complexity that people don't think about. But we also see the sort of integration points of, well, I've got edge clusters that are feeding data to my Amazon clusters that are then doing processing of that information and maybe some type of AI around it and being able to provide feedback real time. So we see a very nice integration between the two environments, but the edge becomes really challenging. Is there resources that can, most of the places there's not a Kubernetes expert at the edge. It's a retail store where someone may walk off with the equipment. Yeah, exactly. We're lucky if they know how to power it on, kind of thing. And so there's a lot more complexities, but our edge solution, as Alex talked about with Kairos, really brings some of the security around it, and then ultimately how we're sort of doing some integration points with Outpost and being able to enable more of those services, common services that we're providing on more Amazon type hardware is really, I think, the area that we're focused on and going towards next.
Awesome. Well, I can drag us across the finish line, I think, here. Like, again, Cy and I have been very excited to talk to you all and hear more about SpectroCloud. Thank you for coming on and joining us here. But how can folks get started with SpectroCloud or learn more about SpectroCloud?
Yeah, I think we have a link to get a quick start with an Amazon sort of offer to support with SpectroCloud and Amazon, a quick start package. You can sign up. We'll have conversations around how it fits with your own environment, and then we can see if it's a good fit and how we move forward. But that would be the place I'd start first. We have other mediums like YouTube, LinkedIn, all those things that you can find more information about us. And then, I think other sessions like this, certainly in the future, maybe will be also warranted.
Yeah, keep an eye out for immersion days that are coming up in partnership with the EKS, AWS EKS team, where we'll be doing hands-on labs.
I mean, of course, you'll be at reInvent too, right?
We'll be at reInvent. We'll see you all there.
For sure.
And KubeCon. I mean,
oh my gosh, I forgot about KubeCon. I need to book that flight. We're going to be at KubeCon, everybody. Salt Lake City, Utah this year. It was in my sweet home here in Chicago last year, but we're going out to Salt Lake City. It's going to be a good time. So definitely stop by. Cy and I will both be there. Our SpectroCloud friends will be there. So definitely drop in and say hi.
It'll be fun.
Cy, anything you want to add?
No, I'm happy. I'm glad to do an outro for us today. Justin, by the way, thank you so much coming on the show here. You are demo extraordinaire. Alex, thank you.
From a hotel room, no less, ladies and gentlemen.
Yeah, by the way, folks watching at home, Justin is in a hotel room in India right now. So very, very early or late, depending on how you look at it. But powered through it like a champ. Thank you, Justin. I think this was actually one of the most engaging demo sessions that I've seen. I think we spent 80% of the episode demoing, which is awesome. Of course. Yeah, and Alex, thank you for joining as well and giving us that solid overview. I think for folks at home, I think I've walked away with a better understanding of how to do platform engineering at scale when working with EKS, but also in hybrid environments, cloud native environments. Really a lot of really cool takeaways here. Strongly urge folks that are watching to click that link to learn more. There's also a number of blogs out there explaining exactly how SpectroCloud and EKS really work together. So take a look at some of the content out there. Justin, Alex, is there a great way for folks to get involved and reach out directly? Maybe they can add you on LinkedIn. Would that be good?
Absolutely.
Yeah. Hit me up, LinkedIn, Twitter, although I don't, well, X now, I guess. I don't X anymore that very much, but I am still there. I still sometimes answer DMs, whatever. But yeah, hit me up. I'm happy to 3 pings.
Awesome. And Justin, your last name is Justin Barksdale, right? Let me see if I get that right. I edited it. Does that look good?
Looks great. Looks
All right,
great.
folks. Make sure you add him on LinkedIn to get in touch directly. Thank you both for being on the show. All right, Ray, what do you think? Ready to call it?
Yeah. Thank you all so much again for joining us today. Stay safe out there. And again, upgrade your clusters.
Upgrade your
Thanks for
cluster.
having us.
I know.